Hi, future GISPs. I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to spend years reading textbooks, getting degrees, paying for prep courses, and searching the internet for information like I did. In this video, I'm going to teach you everything I learned about spatial file types and their applications and limitations. Spatial file types and their applications and limitations is the third section under the data manipulation category of the GISCI Geospatial Core Technical Exam list of knowledge categories. Let's get started with section 503, spatial file types and their applications and limitations. Let's take a look at some vector files. One of the most popular vector files in GIS is a shapefile. The shapefile is the industry standard for file-based vector spatial data. It consists of feature geometry, attribute data, and projection metadata. Each shapefile can contain only one type of vector data: point, line, or polygon. A shapefile is made up of several different files with different extensions in a folder. Shapefile extensions include the .shp extension stores feature geometry. The .shx extension stores indexes for fast retrieval. The .dbf extension stores attribute information. The .prj extension stores projection information. The .sbn and .sbx extensions are optional spatial index files to optimize spatial queries. The .shp.xml extension stores geospatial metadata in XML format. A shapefile must have a .shp, .dbf, and .shx file to work. Shapefiles have other optional components as well. Now let's take a look at the different types of geodatabases. There are three types of geodatabases: a file geodatabase, a personal geodatabase, and an enterprise geodatabase. A file geodatabase, or GDB. A file geodatabase is an object model-based spatial database containing a schema and rules. It is a hybrid and can contain vector, raster, and tabular data, along with topologies, file attachments, and relationships among vector and tabular data. File geodatabases are normally created by a single user and used by one or a few users. Extensions of a file geodatabase are .gdb and .fgdb. A personal geodatabase, or MDB. In a personal geodatabase, datasets are stored within a Microsoft Access data file, which is limited in size to 2 gigabytes. This was the original database format. It isn't used much today. Its extension is .mdb. An enterprise geodatabase. An enterprise geodatabase is based on Oracle, SQL Server, IBM DB2, IBM Informix, or PostgreSQL relational databases. It provides additional capabilities of a relational database management system, which supports versioning and integration with other database systems. An enterprise geodatabase is for organizations with many users. It has full database management system functions for backup, recovery, replication, and SQL support. An enterprise geodatabase uses ArcSDE as middleware between the relational database management system and ArcGIS applications. A GeoJSON. A GeoJSON encodes geographic structures such as points, lines, and polygons using JavaScript object notation and is widely used for web mapping applications. This file type is maintained by a group of developers. Extensions of a GeoJSON can be .geojson or .json. A TopoJSON. A TopoJSON is an extension of a GeoJSON that encodes geospatial topology and typically provides smaller file sizes. The extension for a TopoJSON is .TopoJSON. Computer-aided design, or CAD files. There are a variety of file types that can fall under the CAD category. CAD file types are generated by specific design software, such as AutoCAD or MicroStation, to represent 2D or 3D detailed real-world objects. Many applications can import and export CAD data formats. CAD files are typically employed in design, engineering, architecture, surveying, and construction. CAD data doesn't have to be spatially referenced to an Earth-based spatial reference system like GIS data. The most popular CAD file extensions are .dwg, .dxf, and .dgn. A drawing, or .dwg file. A drawing file type is made with AutoCAD. It can support more complex information than the DXF file type. The drawing file extension is .dwg. A drawing exchange format, or .dxf file. The drawing exchange format file type is made with AutoCAD. It is more widely compatible across software platforms than a .dwg file. A DXF file has no topology but lots of detail. The drawing exchange format extension is .dxf. A design, or DGN file. Design files are made by MicroStation and supported by AutoCAD. The design extension is .dgn. A digital line graph, or DLG file. Digital line graph files are topologically structured vector feature maps developed by the USGS. They include 9 different categories of features: the Public Land Survey System, boundaries, transportation, hydrography, hypsography, non-vegetative features, survey control and markers, man-made features, and vegetative surface cover. DLG data is derived from USGS topographic maps. The last digital line graphs made by the USGS were made in 1990. The digital line graph extension is .dlg. A Tiger file. Tiger is a file format used by the United States Census Bureau to describe land attributes such as roads, buildings, rivers, and lakes, as well as areas such as census tracts. Tiger was developed to support the decennial census. The Tiger files do not contain the census demographic data, but merely the geospatial map data. Demographic data stored in tables at census.gov can be combined with Tiger files to create spatial files with demographic data. Spatial Tiger files are different than the Tiger file type developed for Tomb Raider games. Tiger file extensions are .ft hashtag and .rt hashtag. Scalable vector graphics, or .svg files. Scalable vector graphics is an XML-based vector image format for defining two-dimensional graphics. It has support for interactivity and animation. The SVG specification is an open standard developed by the World Wide Web Consortium since 1999. SVG images can be scaled in size without loss of quality, and SVG files can be searched, indexed, scripted, and compressed. The XML text files can be created and edited with text editors or vector graphics editors, and are rendered by most web browsers. Scalable vector graphics extensions are .svg and .svgz. ArcINFO coverage. ArcINFO coverage is an old file type that stores vector data. Data is stored as a directory within which each feature class is stored as a set of files. ArcINFO coverage files contain spatial data, attribute data, and they can have topology. The ArcINFO coverage file type was replaced by the feature class. ArcINFO coverage file extensions are .adf, .rat, .sec, .pat, .txt, .nit, .dat, and .dir. An ArcINFO interchange file. The ArcINFO interchange file type is used to transfer vector data between machines. It uses a .eoo extension that increases to .eo1, .eo2, etc. if the interchange file is composed of several different files. A portable document format, or PDF. A PDF can store vector or raster image data. The PDF is a standard format for publishing documents and maps. The PDF extension is .pdf. The enhanced meta file, or EMF. Enhanced meta files are used by the graphic design industry for printing. They can store high-quality vector and raster data. The enhanced meta file was created to replace the Windows meta file, or WMF. The enhanced meta file extension is .emf. Geography Markup Language, or GML. Geography Markup Language is an XML-based language for expressing geographic features developed by the Open Geospatial Consortium, or OGC. GML is a modeling language for geographic systems, as well as an open interchange format for geographic transactions on the Internet. GML can store vector and raster data. GML uses a tag-based structure similar to HTML. GML is an ISO standard, ISO 19136. GML replaced the Spatial Data Transfer Standard, or SDTS. The Geography Markup Language extension is .gml. Keyhole Markup Language, or KML. Keyhole Markup Language is an XML format used by Google and other mapping programs to store and display geographic data. KML stores information about how data is visualized, whereas GML stores information about the locations and attributes of geographic data. KML was developed for use in Google Earth and became a standard of the Open Geospatial Consortium, or OGC, in 2008. KML uses a tag-based structure similar to HTML. The Keyhole Markup Language extension is .kml. Keyhole Markup Language Zipped, or KMZ. Keyhole Markup Language Zipped is a compressed file format used for storing geographic data, including KML files, as well as associated resources, such as photos, icons, and other files. KMZ is used to bundle and transmit vast amounts of geographic data in a single file. The keyhole markup language zipped extension is .kmz. Postscript, or PS. Postscript is a page definition language used in electronic publishing and desktop publishing. It's a programming language that can be used for a variety of purposes, including defining vector graphic files. The Postscript extension is .ps. A well-known text, or WKT file. Well-known text is a text markup language for representing vector geometry objects defined by the OGC in their simple feature access. The well-known text extension is .wkt. Now that we've taken a look at some of the vector file types commonly used in GIS, let's take a look at some of the raster file types commonly used in GIS. Tagged image file format, or TIFF, TIFF. Tagged image file format is a lossless image file format used for storing raster graphics. It's commonly used by photographers, graphic artists, and the publishing industry. TIFF files are known for their high quality, flexibility, and near universal compatibility. The tagged image file format was originally developed by the Aldus Corporation for scanners in the 1980s. Tagged image file format extensions are .tiff and .tif. A GeoTIFF. The GeoTIFF file type is a public domain metadata standard that allows georeferencing information to be embedded within a TIFF file. It is a sidecar file for the TIFF file type. It can contain information about map projections, coordinate systems, ellipsoids, datums, and more. The OGC published GeoTIFF standards in 2019. The GeoTIFF extension is .tfw. Joint Photographic Experts Group, or JPEG, JPEG. The Joint Photographic Experts Group file type is the most widely used method of lossy compression for digital images. The degree of compression can be adjusted, allowing a selectable trade-off between storage size and image quality. JPEG typically achieves 10:1 compression with little perceptible loss in image quality. JPEG extensions are .jpg, .jpeg, .jpe, .jif, .jfif, and .jfi. JPEG 2000. JPEG 2000 is a newer version of JPEG. JPEG extensions are .jp2 and .jpx. The image file, or IMG. An image, or IMG, file. There are several file types with a .img extension. One file type used in GIS is a planar bitmap graphics file using simple run-length encoding. It's used by the Earth Resources Data Analysis System for aerial imagery. More commonly, .img file types are used for storing disk images of hard drives. The image file extension is .img. An ArcGIS Grid, or ADF file. The ArcGIS Grid file type is a proprietary format for raster datasets developed by Esri. It has two formats, ArcINFO Grid and ArcINFO ASCII Grid. A Network Common Data Form, or NetCDF file type. The Network Common Data Form is a set of software libraries and self-describing, machine-independent data formats that support the creation, access, and sharing of array-oriented scientific data. The Network Common Data Form is used for multidimensional scientific data such as climate models. The Hierarchical Data Format, or HDF. Hierarchical Data Format is a set of file formats such as HDF4 and HDF5. It was originally developed at the U.S. National Center for Supercomputer Applications to store and organize large amounts of data. Hierarchical data format extensions begin with .hdf. A graphic interchange format, or GIF. Graphic interchange format is a digital file format for images and short animations that was created in 1987 by CompuServe. GIFs are raster files that can support up to 256 colors and 8 bits per pixel. They can be used to combine images or frames to create basic animations. GIF files are popular for transmitting and storing graphic files because they use a lossless data compression format called LZW, which means no information is lost during compression. This results in small file sizes that make GIFs easy to share and load quickly on websites and social media platforms. The graphic interchange format extension is .gif. The USGS Digital Elevation Model, or DEM, file type. The USGS Digital Elevation Model is a geospatial file format developed by the United States Geological Survey for storing a raster-based digital elevation model. It is an open standard and is used throughout the world. It has been superseded by the USGS's own SDTS format, but the format remains popular due to large numbers of legacy files, self-containment, relatively simple field structure, and broad mature software support. The USGS Digital Elevation Model extension is .dem. A tape archive file, or TAR file type. A tape archive file combines multiple files into a single archive for backup or distribution. The Landsat imagery is initially stored in zipped TAR files by the USGS. TAR.gz is a zipped TAR file. Tape archive file extensions are .tar and .tar.gz. LiDAR Aerial Survey, or LAS files. The LiDAR Aerial Survey file type is a widely used binary format designed to store 3D point cloud data collected by LiDAR surveying systems. Each LAS file contains a collection of points with X, Y, and Z coordinates, attributes, intensity values, return numbers, and classification codes. The LiDAR Aerial Survey file extension is .las. LAS zipped, or LAZ files. The LAS zipped file format is a compressed version of the LAS format. It was developed in 2007 as an open source solution. LAS zipped reduces the file size of LAS files while retaining all the original data. The LAS zipped file extension is .laz. Enhanced Compression Wavelet, or ECW file type. The Enhanced Compression Wavelet file type is a proprietary, lossy wavelet compression image format used for aerial photography and satellite imagery owned by Intergraph. Georeferencing information can be embedded in the file. The Enhanced Compression Wavelet extension is .ecw. Multi-Resolution Seamless Image Database, or MrSID MrSID files. The Multi-Resolution Seamless Image Database file format was developed and patented by LizardTech for encoding of georeferenced raster graphics. It can be lossy or losslessly compressed from GeoTIFF, ECW, LAS, and other image file types. MrSID files encode multiple resolutions that work like pyramids, but without creating extra files. When you view MrSID files, it only decodes the resolution level that you need. The Multi-Resolution Seamless Image Database extension is .SID. Raster Auxiliary Files. Raster auxiliary files store information that a raster cannot store, such as statistics, histograms, tables, pointers, and projection information in a sidecar file. Raster auxiliary file extensions are .aux and .aux.xml. A world file. A world file is a 6-line plain text sidecar file used by geographic information systems to georeference raster map images. The file specification was introduced by ASCII. A world file can be used with GIF, JPEG, JPEG 2000, PNG, and TIFF files. World files override geographic data stored in the header of accompanying files. World file extensions are .gfw, .jgw, .j2w, .pgw, and .tfw. A raster catalog. A raster catalog isn't a file type. It is an ASCII tool for storing a collection of raster datasets defined in a table in which the records define the individual raster datasets that are included in the catalog. Raster catalogs can be used to display adjacent or overlapping raster datasets without having to mosaic them together into one large file. Geodatabases support raster catalogs. A Mosaic Dataset. A Mosaic Dataset is an ASCII raster catalog used to manage, display, analyze, serve, and share imagery and raster data. Mosaics can create a continuous image surface across a large area. Mosaic datasets can store multi-dimensional collections of time series layers. Geodatabases support Mosaic datasets. Those were some of the raster file types commonly used in GIS. Now let's take a look at some other file types used in GIS. A geopackage. The Geopackage is an open, universal format for storing geodata based on SQLite. The Geopackage was defined by the Open Geospatial Consortium, or OGC. It can store vector and raster data. It is an SQLite container. The Geopackage encoding standard governs rules and requirements of content stored in a Geopackage container. There are Geopackage standards for storing vector features, tile matrix, raster maps, attributes, and extensions. The Geopackage extension is .gpkg. Now let's take a look at some encoding techniques. The American Standard Code for Information Interchange, or ASCII. ASCII is a standard way of encoding characters as 7-bit strings of zeros and ones. 3 common ASCII file types are DAT, CSV, and TXT. Most programs can read these files. American Standard Code for Information Interchange extensions include .data, .csv, and .txt. Band interleaved by pixel, or BIP. Band interleaved by pixel is one of the 3 primary methods for encoding image data for multi-band raster images in the geospatial domain, such as images obtained from satellites. BIP is not in itself an image format, but it is a method for encoding the actual pixel values of an image in a file. Images stored in BIP format have the first pixel for all bands in sequential order, followed by the second pixel for all bands, followed by the third pixel for all bands, etc. Band interleaved by line, or BIL. Band interleaved by line is one of the 3 primary methods for encoding image data for multi-band raster images in the geospatial domain, such as images obtained from satellites. BIL is not in itself an image format, but it is a scheme for storing the actual pixel values of an image in a file band by band for each line or row in the image. For example, given a 3-band image, all 3 bands of data are written for row 1, then all 3 bands of data are written for row 2, and so on and so forth. Band sequential format is one of 3 primary methods for encoding image data for multi-band raster images in the geospatial domain, such as images obtained from satellites. BSQ is not in itself an image format, but is a method for encoding the actual pixel values of an image in a file. BSQ format is a very simple format, where each line of the data is followed immediately by the next line in the same spectral band. This format is optimal for spatial or XY access of any part of a single spectral band. Header georeferencing. Some files store georeferencing information in the header, such as ERDAS, BSQ, BIL, BIP, GeoTIFF, and grid files. Freeman Codes. Freeman Codes are a way of encoding lines for vector files. Lines are coded with a chain of numbers, such as 0 through 7. Each number represents a different direction. Now let's take a look at some data compression methods. Run length encoding. Run length encoding is a lossless compression method where sequences that display redundant data are stored as a single data value. Run length encoding is effective for compressing files with large, homogeneous areas. It is not effective for compressing highly variable datasets. LZ77, and LZ78. LZ77 and LZ78 are lossless pyramid data compression algorithms created by Abraham Lepel and Jacob Ziv. They are used for the basis of many other LZ compression algorithms. They are dictionary encoders that use a sliding window compression to replace repeated occurrences of data with references to a single copy of that data. Now you know everything that I learned about spatial file types and their applications and limitations to easily pass the GISP exam. Don't forget to thumbs up and subscribe to my channel so that I can keep helping people pass the GISP exam and achieve the rewarding careers in GIS that they deserve. You can also find everything I learned to pass the GISP exam in my book, The Ultimate GISP Exam Study Guide, available on Amazon. My study guide is an easily understandable, comprehensive, graphical, all-in-one resource for passing the exam. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam.